and get started on the tutoring for the math. Can everybody hear me okay, or do I need to turn up my volume a little more?
I can hear you.
Okay. All right. So, all right. So what we'll do is we'll just kind of start just from the beginning, and we'll do some problems each from each area. Or do y'all want me to do just like answer specific questions first?
I have one specific question I'd like to ask.
Okay. What you got?
I'm not even sure if some of this questions like this will be on the test, but
Okay.
how many milliliters of a 15% solution are needed to
No,
deliver?
no, no. So even in pharmacology, y'all won't have any like that. Okay. Because
Okay.
that's really not anything in real life that you're going to use. I mean, yes, I mean, you know, there is a way to figure that out and stuff, but that's really nothing as a nurse that you're really gonna use. So we don't really force y'all to make that because it's very, I mean, to understand that because it can be it can be very confusing. So
Yes, ma'am.
yes,
Okay,
so,
thank you.
so don't worry about those. Okay.
Okay.
Okay. All right. Any other questions? If not, we'll just kind of start from the beginning. Okay. All right. So what I'm gonna do is share my whiteboard. Excuse me. Let's see, where is my whiteboard? There it is. All right, can everybody, hold on, it's still loading. All right, can everybody see my whiteboard? Yes, okay. All righty, so what we'll do is we'll just kind of start from the beginning, okay? And what we'll do is as we go along, I'll be writing some, oh Lord, rules down as we go, okay, for different, whether we're doing decimals, fractions, etc. Because if you don't know these rules, it's going to be hard to know how to do um, the the problems once you get started, okay? So the first thing, I think chapter one fractions, y'all? I'm trying to
Yes.
remember. Okay. All right. So the first thing that we're going to do before we get into fraction questions, first thing that we're going to do is we're going to talk about how to reduce and convert to mixed numbers, and then from mixed numbers to improper. No, y'all, Lord, I'm sorry, y'all. I can't get my words out today.
Improper
Um,
fractions.
Thank you. So, so the first thing is let's talk about rounding, okay? Because remember what we talked about with the prior tutoring is that even if a question does not say round to the lowest terms um, or change the improper fraction to a mixed number, you always want to think about how you would talk to somebody, okay? So if you have an answer that's 10/20ths, would you say, give me 10/20ths of that medicine, or would you say, give me 1/2? Okay. So even if the directions doesn't say to round, because in real life, when you're figuring out a medication, is the medication order going to tell you to round to the lowest, I mean, reduce it to the lowest uh, number. It's not. So anytime you want to that final answer, you always want to think about how would I say it to somebody else. So let's talk about how do we get from 10/20, how do we get to 1/2? So we want to find a number that will go into both of these numbers equally. And this is what I always tell people. Sometimes, this one's kind of easy because it's 10 and 20, but let's say it was a little harder number and you couldn't really figure out what is the largest number. You can always start small. So we know 2 goes into 10, right? 5 times. And we know, can y'all hold on 1 second? Hello. Hello. Hey.
Ventura was trying to get in still.
I
Not sure
just
she.
let in two people, not
Okay.
sure who it was.
Okay. Oh,
Um, so yeah, I'm not sure who it was, but I did just let in two people.
okay.
All right, so when we look at what I was saying just now is so even if you can't find, or figure out like what the biggest number is that'll go in both, you can always start small. So 2 goes into 10 5 times, 2 goes into 20 10 times. Now I can reduce it again, right? 5 goes into 5 one time, 5 goes into 10 two. So even if you can't think of or realize there's a bigger number that'll go into both, you can always start with a smaller number. You may just have an extra step of rounding, but you'll still come up with the same answer. Okay, so don't stress about trying to find, I can't think of what the biggest number is that goes in both of them. Okay. All right, so next, let's talk about changing from um, improper fraction, excuse me, a mixed number to an improper fraction, okay? So when we do that, what we're going to do is, so first of all, an improper fraction is going to be where the top number is bigger than the bottom number, okay? So the way that we're going to do that is we're going to multiply 3 times 2, which is going to give me 6. And then I'm going to add that 6 to the top number. 6 plus 1 is 7. And then I'm just going to bring over my denominator. So my improper fraction would be 7/3. Okay. Now, as we go along, if you don't understand something or you need me to redo it or something like that, just let me know. Okay. All right. So now let's say we had to go from an improper fraction to a mixed number, okay? So let's say we have 8/3, okay? And we want to change that to a mixed number. So the way that we're going to do that is we're going to divide. We're going to see how many times does 3 go into 8. So remember, when we're doing long division, the top number always goes inside the little house here, okay? And then the bottom number is going to be on the outside. So 3 goes into 8 2 times. 2 times 3 is 6. Okay, so when I subtract that, I have 2. Now, can 3 go into 2? It cannot. Okay, so what we're going to do, no, I'm sorry. We're going to stop right here. Sorry. I'm moving on for something else. Sorry. All right, so how many times did 3 go into 2? How many times did 3 go into 8? Golly, I got to get my brain right today. So 3 went into 8 2 times. So 2 is going to be our whole number. Okay. Then how many did we have left over? We had 2. So the remainder is going to be your top number. And your denominator is just going to be brought over. So our answer would be 2 2/3. Does that make sense? All right. Yes. All right. So let's do this. I'm going to give y'all 3 problems and I want y'all to do them and put the answers in. Okay. First of all, I want everybody to go to the chat and change it from everybody just to my name. That way nobody else knows what you're sending me. And then I'm going to put 3 problems up here and then you'll number them in the chat and give me the correct answer. Okay. So the first one, you're going to reduce. Okay, that's a 0. All right, the second one, you're going to convert from a mixed number to a improper fraction. Okay, and then the third one, you're going to go from that mixed number to a, excuse me, improper fraction to a mixed number. So let's see, we'll do 15/2. Okay. And whenever you give me the answers, if you just wait until you get all three answers and then say 1, 2, and 3 and give me the answers, okay? And then we'll work them together after, okay? All right. All right, Lori, yours is correct. Let's see. Maya, let's see. All right, Maya, on your first one, is that supposed to be 1/5 or 1.5? Hmm. All right, Jasmine, your first one is correct.
It was just 5. Not
Okay,
number 1 is 5. And then I accidentally pressed enter, so I'm about to do number 3.
okay. All right, and then relook at relook at number 1, okay? Because part of it, you're not quite correct on that one, okay?
Okay,
All right,
thank you.
All right, suppose I'm here. Hmm. All right, so Ashley, yours is correct. All right, Jasmine, yours is correct. Okay. Okay, let's see, Avis. All right, Avis, look at number 3 again, okay, Avis? Okay, let's see. All right, Matthew, yours are correct. Both, is it Asia? I'm not sure if I'm saying it right. Yours, so let's see. Bovia, look at number 3 again, okay? You have the numbers correct, you just don't have them in the right spots, okay? All right, let's see, Gloria. All right, Gloria, yours is correct. Okay, Maria, your number 1 is correct. All right. How many people do I have on here? 14, okay.
Miss Sanchez, is mine showing up, Erica?
Erica, you said?
Yeah.
Let me see if I overlooked you. Oh, there it is, Erica. I did overlook you. 17, yours is correct, Erica. All right, let's see. All right, Avis. Okay, Avis, number 3, the new one you put in is correct. Maria, number 2 is correct. Let's see. Okay. Bovia, number 3 is now correct. All right, Mara, look at your number 3 again, Maya, okay? Let's see. All right, Williams, S. Williams. Let's see. Look at number 1 again, S. Williams. And if you're not sure on it, we're going to work it together shortly, okay? All right, Maya. Oh, I taught you on it. Okay. 17. Okay, so Shy. I don't know if I'm saying it right. Shai. Is it Shay?
It's shy.
Shy, I had it right first time. Okay. That is correct for number 2. Maria, number 3 is correct. Maya, number 3 is correct. Okay. All right, y'all. So y'all ready to go ahead and work them together? All right, so let's look at this first one. All right, so we're reducing to lowest terms, okay? So if we found the greatest common denominator, it would be 20. But let's say you didn't catch 20, okay? So we could start with 10. So 10 goes into 20 2 times. 10 goes into 100 10 times. And then I can reduce that again, right? 2 goes into 2 1 time. 2 goes into 10 5 times. So our answer was 1/5 on that one. Now let's look at our second one. So we're changing this to an improper fraction. So we're going to multiply 5 times 3, which is going to give us 15. And then we're going to add that to our top number, which will give us 17. And then we're just going to bring over our denominator, and our answer would be 17/5. Okay. And then on the last one, so we're got to figure out, we're going to change this to a mixed number. So we got to figure out how many times 2 goes into 15 and then how many we have left. All right. So remember, 15 is our top number. So it's going to go inside of our house. So 2 goes into 15 7 times. 7 times 2 is 14. And then we have 1 left. So our here, our whole number is going to be the top number. Okay, so that's going to be our 7. Our remainder is going to be our, I'm sorry, our 7 is going to be our whole number. Our 1 is going to be our top number. And then our 2 is just going to carry over. So our answer would have been 7 1/2. Any questions on those? Okay. All right, so let's move on to multiplication and division of fractions, okay? All right. So I'm trying to remember where. Oh, there it goes. Okay, that's what I was looking for. All right, so now the first thing that we're going to do is we're going to write out, we're going to get to my color here. Okay, so first thing we're going to do is multiplication, okay? So let's say we have 2/3 times 1/4, okay? When we do multiplication of fractions, y'all, you're just multiplying straight across. So 2 times 1 is 2, and then 3 times 4 is 12. Now, can I reduce this anymore? I can, right? So 2 goes into 2 1 time, 2 goes into 12 6 times. Any questions on that, on how to multiply them? So if you can multiply a fraction, then you can divide a fraction, okay? So what we're going to do is we're going to say, we're just going to do the same problem, except we're going to divide it. And we do one more, sure. All right, so we're going to do one more multiplication first, okay? So let's do, let's say 7/8 times 2/3. Okay. So what we're going to do again, since it's multiplication, means we're going to just multiply straight across. So 7 times 2 is 14. And then my 8 times 3 is 24. So now, can I reduce this more? And I can, right? So I'm going to start with just 2. So 2 goes into 14 7 times, and 2 goes into 24 1, 2, 12 times. So my answer would be 7/12. Can I reduce that 7/12 anymore? So normally, for the most part, y'all, and there is a few exceptions to this rule, but normally if it's a odd number and an even, one of each, normally you will not be able to reduce it. Every now and then there is, again, a few exceptions to that rule that you'll come across, okay?
Ms. Sanchez,
Uh-huh.
how do you know when to find the greatest common denominator and the least common denominator?
So this is the thing, the goal, anytime that you're reducing, you're supposed to be looking for the greatest common denominator, but that stresses students sometimes because y'all can't, sometimes you just don't know what that greatest one is. So I always tell y'all, just start with a small number, even if it's a least, even if it's a common least denominator, you
Okay,
can divide it and then go, do more steps and just keep reducing until you get to where you can't reduce it anymore.
yes, ma'am, thank you.
Okay. I know in school, like younger years, like you had to find the greatest because, in order to get your points or whatever. But what I like to teach y'all, as long as you come to that, to where it's reduced down to where it can't be reduced anymore, it doesn't matter as long as it's a common denominator. It doesn't matter if it's the largest or the smallest or somewhere in between. Okay. As long as you're coming up with the right answer. All right, so now let's look at the division, okay? And what we're going to do is we're just going to use these same problems that I have on the board, except we're just going to divide them, okay? So we have 2/3 times 1/4. Oops, I'm sorry. That's not what I wanted to do. Divided by 1/4. So the very first thing that you're going to do is that you're going to rewrite your problem. So I'm going to bring down my 2/3. And then your division sign is going to change to a multiplication sign. Okay. And then your second fraction is you're going to take the reciprocal, which means you're just going to flip it upside down. So instead of having 1/4, you're going to have 4/1. Now it's a multiplication problem now, right? So what did we just do with the multiplication problem? We just multiplied straight across. So 2 times 4 is 8. 3 times 1 is 3. Now, can I leave this answer this way? Can I say, hey, bring me 8/3? You're going to look at me like I got 3 heads, right? So how do I change that to a mixed number? So remember, we're going to see how many times does 3 go into 8. So 3 goes into 8 2 times. 2 times 3 is 6, and I have 2 left over. So my 2 is going to be my whole number. My remainder is going to be my top number. And then remember, my bottom number is just going to bring it over. So my answer would be 2 2/3. Y'all want to do another one of those?
Yes.
Okay. All right. So we're just going to do this one right here. Okay. We're just going to do the same problem. except we'll just do it as a division. Okay, so 7/8 divided by 2/3. All right, so what's the very first thing I need to do? I need to rewrite that problem. Okay, so I'm just going to bring down my first set of numbers, 7/8. All right, and what am I going to do with this division sign? That is going to change to a multiplication sign. And then my 2/3, what do I need to do? I need to flip that over, right? So we're going to have 3/2. All right, so now, since it's now a multiplication, how do I multiply a fraction? Just straight across, right? So 7 times 3 is 21. And 8 times 2 is 16. So can I leave this as this improper fraction? No. Okay, so 16 goes into 21 how many times?
One.
One time. Okay, we wanted, so it goes in there 1. 1 times 16 is 16, and I have 5 left over. So I have 1. My remainder is going to be my top number. And my bottom number is going to be 16. So my answer, sorry, that was pretty messy. So my answer would be 1 5/16. So practice is what's going to take it to get these, right? Okay, so let's do, I'm going to give y'all a practice. Oh, actually, let's do one other thing first, okay? All right, let's say we had, 1 1/2 times 3/4. So what do I need to do before I can work out this problem? Anybody know?
Change it to an improper fraction.
Okay, so in order to multiply this, we cannot have that mixed number. We've got to change it to an improper fraction. So remember, how do we change to that improper fraction? 2 times 1 is 2. And then 2 plus 1 is 3. So I'm going to have 3. And remember, my denominator always stays the same. Okay. Then I'm just going to bring this over. So how do I multiply a fraction? Straight across, right? So 3 times 3 is 9. And 2 times 4 is 8. Now, again, can I leave that answer in that form? No. So how many times does 8 go into 9? 1 time. And how many do we have left over? So 9 minus 8 is 1. And then we're going to carry over the bottom number. So the way I got that is 9 divided by 8. 8 goes in there 1 time. 1 times 8 is 8. And we had 1 left over. That's my top number. And then my denominator is going to stay the same. Any questions on the multiplication? Now, same thing on division, y'all. If there is a mixed number, you have to make that into a improper fraction before you can work the problem out. Okay. All right. So let's move on to adding and subtracting. Okay. So with adding and subtracting, Give me 1 second. I want to try to figure out something real quick. Where is my, okay. Nope, that's not what I'm trying to do. Well, there's a way to change the page, but I can't find it. Okay, so what we're gonna do, we'll just move on. Trying to figure out how to, okay. So, adding and subtraction. So when we're adding and subtracting fractions, we got to make sure that they have the same denominator, okay? So 1/2 plus 1/2, okay? Since our denominators, which is our bottom numbers, are the same, all we have to do is add, okay? So 1 plus 1 is 2. And in your denominators, you're just going to carry it down. Okay, so I'm adding my top numbers. The denominators that are the same, they're just going to be brought down. Okay, so can I leave this like this? Two twos?
No.
No. So what's 2 divided by 2?
1.
So my
1.
answer would be 1. Okay. All right, so let's look at another one. Okay, let's say you had 5/6 minus 1/6. Okay, so is my denominators the same? They are, so I don't have to do anything. I can just go ahead and work my problem. So 5 minus 1 is what?
4.
So I'm trying to get my thing situated here. Okay, so 5 minus 1 is 4. And then what am I going to do with my denominators?
Leave it the
Just,
same.
just leave it the same. So now, can I leave this answer as 4/6?
No.
Oh, I can reduce it. And what can I equally go into both of these numbers?
2.
2.
Oh, my nose is itching. So 4 divided by 2 is what?
2.
2. And 6 divided by 2 is?
3.
3.
All right. Now, can that be reduced anymore?
No.
So that would be my answer. All right. So now let's look at some that are not with the same denominators. All right, so let's say we had 1/3 plus 2/4. All right. So what I'm going to do is there's 2 different ways that you can do it, but I'm going to show y'all a way that I find is easiest for the students, okay? So the way I was taught is different than the way that I'm going to teach y'all right now. But through the years, the way whenever I have been tutoring students, this is what they teach me that y'all have been taught. Okay, so what you're going to do is your denominators. You're going to take those and then you're going to multiply them times the opposite fraction. So this is what I mean. So I have this 3. I'm going to take it and I'm going to multiply it times 2. I'm going to multiply it times my 4. Okay, so this is going to give me, what's 2 times 6? I mean, sorry, 2 times 3 is 6. And 4 times 3 is 12. Now, I'm going to take this denominator and I'm going to multiply it times the 2 top numbers. So 4 times 1 is 4. 4 times 3 is 12. Now, is my denominators the same? Yes. So now I can go ahead and work my problem. So I am going to add 4 plus 6 is going to give me 10. And then what do I do with this same denominator? I'm just going to carry it down. So I have 10 12s. Can I leave it that way? Is that in lowest terms?
No.
No. So I would use 2. So 2 goes into 10 5 times, and 2 goes into 12 6 times. Does that make sense? All right, let's do another one, okay? All right, so let's do a subtraction, okay? All right, and the subtraction is going to be the same thing. The only difference is that you're going to be subtracting, okay? So let's say we have 4/5 minus 1 1/2. All right, so what's the first thing? So first thing I'm going to look and I'm going to say my denominators are not the same, okay? So I know that I'm going to have to make them the same, okay? So I am going to take my denominator here, and I'm going to multiply it times my two bottom numbers. 5 times 1 is 5. 2 times 5 is 10. Now, for my top one, I'm going to take my bottom denominator, which is 2, and I'm going to multiply each of them by 2. So 4 times 2 is 8. 5 times 2 is 10. Now, is my denominators the same? Yes, now they're the same. So now I can go ahead and work my problem. So 8 minus 5 is 3. And remember my denominators are the same, and I'm just going to carry that down. So my answer is 3/10. Do I need to reduce this any further?
No.
No. Do y'all need another one of those? Really, y'all, it's going to take practice.
What
You
if
know,
you
really,
have 3 fractions?
you won't have 3 fractions. I mean, on the test, you won't have 3 fractions. And probably in real life, when you're adding or subtracting partial medications, it's usually not going to be 3. It's going to usually be 2. But if you did have 3, it would be the same thing. You would just get that common denominator, but don't worry about that because you're not going to use more than 2 in nursing, and you're not going to have more than 2 on the test, okay? All right, any other questions on those?
Are we gonna have borrowing fractions on the
I'm sorry, which fractions?
borrowing? Like if it was
Like,
mixed numbers, you would have to like borrow or something like
oh, no, I'm not going to do that to y'all. No,
Okay.
because probably in real life, you're not going to be dealing with that, but no. So you won't have to worry about the borrowing. Okay. Any other questions on the fractions? Okay, so let's do this. Let's move on to converting between percentage. Where's my erase? Okay, here it goes. So we're going to convert between percentage, fraction, ratio, things like that. Okay. All right. So what we're going to do is we're just going to draw us a board, or not a board, but table. Okay. And we have percentage here. We have decimal. Well, that's supposed to be decimal, y'all, but it's a little hot mess there. But all right. And then we have fraction. and ratio. So on the test, you're going to have to convert between each of these, okay? So let me make up some numbers real quick. Okay, let's say 0.358. All right, let's say 6. Mm, let's just do an easy one. Just say 1/2. All right, and then let's say 3/8, and let's say 102%. All right. So when we're going between units, okay, what you want to do first is when you're looking, if I have a decimal, okay, that I need to convert to a percentage, to a fraction, and to a ratio. So to figure out some of these things, you have to have others, okay? And I'm going to explain that as we go, okay? So anytime that we go from a decimal to a fraction, you're going to move your decimal point 2 places to the right, okay? So that would give us 35.8%, okay? So move decimal 2 to the right, okay? Now, whenever I do a fraction, okay, I need to know all right, so now when I'm going from a decimal to a fraction, what I'm going to do, and there's a rationale behind this, but just do what I tell you to do, okay? Don't worry about why, okay? So what we're going to do is we're going to take the whole numbers that's in here. I mean, like, not the whole number, but the actual numbers. So we have 3, 5, 8. We're going to draw a line and I'm going to put a 1. And then I'm going to count the number of numbers that are after the decimal point. So 1, 2, 3, and I'm going to add that many zeros. 1, 2, 3. Did that make sense? All right, so we had our 0.58. So we're just going to drop the decimal in the 0 and write 358. We're going to put a 1, and then I'm going to count how many numbers are behind that decimal point. We got 3. 1, 2, 3, and that's my fraction. Now, can I reduce this?
Yes.
Yes. Okay. So, to be honest, I would probably start with 2 and then figure it out from there. All right. So, who's got their calculator? I know I won't give y'all big numbers like this on the test. Okay. So let's see. I just pull these out my head. Sometimes they're a little too big. All right. So if we divide 58 divided by 2. So if I divide 358 divided by 2, it's going to give me 179. And then 1,000 divided by 2, is that going to be 500? It's going to be 500. Now, is that in lowest terms? It is.
Yeah.
All right, so this would be 179 over 500. So now, how do I do the ratio? So the ratio, y'all, all you're going to do is you're going to take your fraction You're going to take the top number. You're going to put, what's that thing called? A colon. And then the bottom number. And that's it. Did I lose anybody? All right, so let's do the second one. So if I have a fraction, okay, the first thing that I'm going to have to know, well, the first thing that's the easiest thing to do is go from fraction to ratio, right? So 1/2 is going to be 1 to 2. Okay, so to use a ratio, we may say something like there's 1 male in the class for every 2 females. Okay, so that's how we kind of use a ratio in a sentence. Okay, 1 to 2. Okay, or I have 1 strawberry for every 2 bananas I have. Okay, all right, so now what would be the next thing that I would need to, I'm not getting, okay, so on the ratio, all you're doing is taking your fraction and taking the top number, putting it here, putting a colon, and then putting the bottom number. Okay, that is how you go, that's how you make a ratio. Okay, now we're going to talk about in a little bit how to tell if your ratios are proportioned, or to how to find missing numbers for ratios. But just for right now, from converting, you're just going to take that fraction and just rewrite it with the colon in the middle, that top number and bottom number. Okay. All right. Now, on this one, can I figure out my percentage without knowing my decimal? No. Okay. So the way I'm going to do it is, how do I take this fraction, make it into a decimal? What I'm going to do is I'm going to take my top number, which is 1, and I'm going to divide it by the bottom number. Y'all, anytime you see something set up like this line just means division. Okay, so I'm going to 1 divided by 2. Okay, so if I take 1 divided by 2, can 2 go into 1? It cannot. Okay, so it's going to go in 0 times. 0 times 2 is 0. Now, can that 2 go into 1? It can't. So remember, I'm going to add my decimal. I'm going to bring my decimal point up. And I am going to add a 0 here. Bring that 0 down, which is going to give me 10. Now, can 2 go into 10? It can. 5 times. So 5 times 2 is 10. So 1/2 would equal 0.5. Does that make sense? So to get a decimal from a fraction, I'm going to divide the top number by the bottom number. Now, remember when we did decimal to fraction, we moved 2 places to the right. Okay. Hold on a second, y'all. Wait, we did. Okay. Hold on a second, y'all. That was right. All right. Okay, I'm sorry. I'm drawing a blank. Okay. So decimal to the fraction is 2 places to the right. So I'm going to take that decimal and go 1, 2, and I'm going to put a 0 right there. So it's going to be 50%. Does that make sense? So because I'm going from a decimal to a percentage, I'm going to drop. When I move this decimal point, it's no longer right there. Okay, so it's now behind the 0. So it's going to be 50%. Does that make
That's
sense?
where the 0 came from, because I thought it was just 0.5.
So it's going to be, because when you move, let me write it over here. So we had 0.5, okay? And you're going to move the decimal point 2 places to the right. So it's going to be 1, 2, okay? So this is a new place that's going to need a 0 now, okay? Because your decimal point is here. So when you're going from decimal to percentage, you always move it that 2 places to the right. So that's going to give us an additional place that needs a 0. Does that make sense? If I just move it, let's see if I have 0.5. If it just moves to right here, it would be 5%, and that would not be correct, okay? So you got to move it that 2 places to the right, and in that second little hump, you're going to put a 0 there.
Okay, so 1/2 as a decimal is 0.50.
Yes. No, no. Well, yes, but, okay, let me do this. Yes, so 0.50, okay, is 1/2 as a decimal, but in nursing or in medical, can I have that trailing 0? You
No.
cannot, so it would be 0.5.
Okay, so it is just 0.5.
Correct, it is, but when we convert it, hold on a second, my computer's about to fall. Let me find my. All right, but when we convert it, we're going to have to add that 0 back to make it 50%. Does that make sense?
Okay, so if I was to put just a 0.5 on the test, that wouldn't be wrong in the
For
decimal.
the decimal, correct. For the decimal would be, this is what your decimal would be, 0.5.
Okay, all right.
Okay, does that make sense now? Hopefully.
Yep, got it.
Okay. All right, so our next one now is we have our ratio that we're going to start with. So what would be the easiest thing to convert to first with the ratio?
The fraction.
The fraction, okay? And then what's my fraction going to be?
3/8.
Just 3/8, okay? All right. Whoop, that's a little too light. Okay, so now, what would be the next conversion we need to do? Decimal or fraction? Excuse me, decimal or percentage?
Percent.
Okay, can I
Well,
figure
I mean,
out this?
I'm sorry. That's
Decimal. Okay, so how are we going to get that decimal? What are we going to divide?
how many
Good.
times?
Right.
8.
So 3 divided by 8. Okay, so remember our sign means division. So 3 divided by 8. So how many times can 8 go into 3? It's going to be 0, right? So 0 times 8 is 0. And then when I subtract, I'm going to have 3 left. Okay, so again, can 3 be divided by 8? It can't. So I'm going to put a decimal point here. I'm going to bring my decimal point up, add a 0, bring it down. So now can 8 go into 30? It can, and it's going to go in three times. So 3 times 8 is 24. And then when I subtract this, it's going to give me 6. All right, so can 8 go into 6? It cannot. So what are we going to add? I'm going to add a 0. I'm going to bring that 0 down. Now can 8 go into 60? That's going to go, is it 7, y'all? 8 times 7?
7. It's 56.
Okay. All right, so we have our 7. 8 times 7 is 56. All right, now when I subtract this, how many is it going to give me? 4?
4.
All right, can 8 go into 4?
No, gotta bring the 0 down.
All right, so when I bring that 0 down, can 8 go into 40?
Yep, 5 times.
5 times. 5 times 8 is 40. So what is my decimal? 0.375. That makes sense? All right. Now, how do I go from that decimal to percent? What am I going to do with my decimal?
2 times to the left.
To the left or to the right?
Right.
Okay. So 2 times to the right. There we go. So my percentage is going to be 37.5%.
Miss Sanchez.
That makes sense?
Yep.
All right, so now on the next one, we have our percentage. So when we go from percentage to decimal, we're just going to do the opposite of what I did right here, decimal to fraction. That's supposed to be decimal to percent. All right, so this one is just going to be the opposite, right? So percent to decimal, we're going to move 2 to the left. Okay, so where is my decimal in 102?
Behind the 2.
Okay, so behind the 2. So if I'm going to move 2 places to the left, I got 1, 2. So my decimal would be 1.02. Make sense? All right, so now let's convert from that decimal to our fraction. Okay, so I'm going to write this whole number without the decimal, 102. Okay, and then I'm going to do my line. And how many numbers do I have in there? 1, 2, 3. So when I do the math on this one,
I think it's 51 over 500.
okay, so 51 over 500. I'm gonna put another little box down here, y'all. So we're gonna,
Excuse me.
uh-huh,
I don't see you on the board no more. Where are you on the board?
did I run out of board? What all can y'all see, y'all? Can y'all see the 102%?
I can see the board, and it's she's right under the fraction, the last one on the fraction part.
Okay, got it. Thanks.
Oh, you can see it now, okay.
Yes, ma'am.
So sometimes it's just hard for me to know what y'all can see on the board. So what we did is we took the 102 over 1,000 and we divided it by 2, okay? So 2 to reduce it. So 2 goes into 102 51 times, and 2 goes into 1,000 500 times. So our our fraction would be 51 500ths. Now, how would I write that as a ratio? I'm just write the top number with the colon, and then the bottom number is going to be my ratio.
So on the top, where on the very top line, 0.58. Okay, you said to count the numbers behind the decimal, so you can know how many zeros to put under the fraction, which made that 1,000, right?
So this is, so hold on a second. Was it this first one that we did?
The first row, yeah.
Okay. So on this one, so the way it works, what you're going to do is, let me show y'all this. Let me do this. Okay, let me erase. So what's going to happen when you're going from decimal to fraction? Let me make a clarification on that for y'all. Okay. So let's say, like on this first one, we had the 0.58, okay? And then on this bottom one, we had 1.02, okay? So what you're doing is you're just taking the whole, like you're just taking all the numbers and you're getting rid of the decimals and stuff, okay? So the only numbers that are in here is 358, okay? On this one, we have a number before the decimal. So all we're doing is we're dropping that decimal, okay? So 102. So even here, if we just drop the decimal, we would still have to drop the 0 because would we write it this way?
Right.
And then what you're doing is you're going to count, you're going to put your 1 and then however many numbers you had. So we had 3 here. So 1, 2, 3. I guess I should have said it this way. However many numbers up here is how many zeros you do.
Okay, because I
Here,
found behind us this one. I was like, wait a minute.
okay, so maybe I think I worded it wrong. Okay. So on this one, it's gonna be 3 total numbers. Okay. So 3 total numbers up there. So it would be this. Okay. Does that help better? I think I might have said it a little wrong. I guess on this one it was technically correct the way I said it, but in general, when we're talking about all of them, it would be how many numbers are there.
Okay,
Okay.
got it.
And now somebody, let's see. Okay, so the person that just commented, y'all getting it? Okay, yes. Okay, yeah, I think I said it wrong the first time, so hopefully that makes more sense. And then you would just reduce it down from there. So on the exam, y'all, the way it's going to work is you'll have a section that says convert the following to percentage, okay? And it might give you a decimal and it may give you a fraction, okay? Or it may say, convert the following to a fraction, and it may give you a decimal or it may give you a ratio. Okay. So it won't give you this box like this, but if this box helps you kind of break it down and understand it, you'll have scratch paper, just draw the box. Okay. Draw the box out and realize, okay, what do I need to convert first to get to there? Okay. Because you will have that scratch paper. Okay. But I find personally it's easier for me with this box because I can look at, okay, what do I need to convert before I can get to that next step? Okay. Any other questions on these? So you will have to convert, between decimals and fractions, fractions and decimals, decimals and percentages, etc. Okay. All right. Any questions on these before we move on to decimals? Actually, let's do ratio and proportions first because those are quick and easy. All right, I'm gonna erase. Everybody got everything they need off this board? Because I'm gonna erase. All right. All right, so let's do ratio and proportions next because those are pretty easy. So 2 types of ratio and proportions you're gonna have on the test. You're gonna have to have, so you're gonna, let me come up with some things real quick before. Let's see. See, 3, 4, um, actually, do, um, do 8, 2 8 equals 4. Okay. X minus 2 8 equals. Okay. All right. So you're going to have 2 different types of questions on the exam when it comes to ratio and proportion. Okay. The first is where you're going to have to tell if they are proportioned. Not supposed to be tell if they're proportioned. Okay. And when we talk about proportioned, we just mean, are they equal to each other? Okay. So remember when we did multiplications of fractions, it's got an X right here, right? So we multiply straight across. Anytime you see an equal sign between two fractions, it means that this is a ratio, okay? So the way that we work with ratios, instead of multiplying straight across, we're going to multiply diagonal. So 3 times 1 is 3. 2 times 2 is 4. Does 3 equal 4? No. So this is not proportioned. Okay. Now, the next one, and y'all, it doesn't matter which side you multiply first and which side you multiply second. Okay. So 2 times 4 is what? 8. And then 8 times 1 is 8. So is this proportioned? Yes. Easy enough?
Yep. I thought first I thought I was like two-thirds and 1/2.
All right, so all you're doing is that diagonal multiplication, and it's either equals each other, it doesn't. Okay. All right, so now the other part, that the other ones you're going to have to solve for X, okay, or whatever alphabet's on the test, okay? So remember, if I have this equal sign, then how am I going to multiply? I'm going to multiply diagonal. So 2 times 1 is 2. 8 times X is 8X, okay? So my goal is I have to get 8 by itself, okay? I mean, not 8, sorry, X. So in order to do that, I'm going to I'm going to divide 8 to each side. Now, this is going to cancel out, which gives me X. And then 2 divided by 8, or I can just, two different ways I can do this. I can give it the final answer in a decimal, okay? Or I can just reduce this and it's going to be 1/4. Does that make sense?
So on the test, will you take, if we do it in the decimal form, will you take that as correct?
Correct. And if we did this in the decimal form, y'all, your answer would be 0.25 equals X. Okay, so
Simple.
either one of them is correct, whether you give me the fraction or you give me the decimal. Okay, so now let's do the next one. Why is this? Okay, so remember, since it is a ratio, and we know it's a ratio because it's got the equal sign, we're going to cross multiply. And again, it doesn't matter which side you multiply first. So 1x times x is, 1 times x is 1x. All right. And then what's 2 times 3? It's going to be 6. And now remember, I have to get this x by itself, so I'm going to divide both sides by 1. This is going to cancel. And x equals 6. Make sense?
Yes.
All right. Any questions on those? You're going to have 1 or 2 of each of these, okay? All right. Next, let's do our, let's do decimals. All right. All right, so our rules for decimals, okay? When we add or subtract, the decimals have to line up, okay? All right, with multiplication, you're going to count the decimal places at the end. And this is going to, make more sense when we do the problems. And then for division or divide, you got to make the outside number whole. Okay. All right. If you don't know these rules, then you're not going to be able to get the right answer. Okay. So make sure you understand these rules as we go along. All right. So let's do the first one. Let's say we have 5.01 plus 1.1. Okay. So first thing is we're going to line it up to where it's going to be up and down, which is going to be easier to add it. So 5.01. And remember, for add and subtraction, it says our decimals have to line up. So this 1.1 has to go right here because my decimals have to line up. Then I'm going to add. Now, if you want, you can put a 0 there as a placeholder, if that works better for you. Okay, so 1 plus 0 is 1. 0 plus 1 is 1. 5 plus 1 is 6. So our answer would be 6.11. Any questions? All right, so now let's say we had, let's do the same one, but let's do minus. Let's say we had 5.01 minus 1.1. Okay, so again, when I set up that problem, I'm going to have actually, let me do this. All right, so let's do 5.01. And remember, for our rules, our decimal points have to line up. So we're going to have 1.1. All right, and again, you can put that placeholder of a 0 there. So 1 minus 0 is what? 1. Now, can I take 1 from 0? I cannot, okay? So I am going to have to borrow. So I'll make this a 10, and this, I'm borrowing 1 from that one, so it's going to be a 4, okay? So now 10 minus 1 is 9. Remember, my decimal points are just going to stay in the same spot. They're all lined up. And then 4 minus 1 is 3. Any questions on those? Okay. Now, let's do multiplication. So we're just going to use the same numbers, y'all, and we're just going to multiply them, okay? So 5.01 times 1.1. Now, we're not going to worry about where the decimals are or anything until the very end, okay? So we're going to go ahead and do our multiplication. 1 times 1 is 1. 1 times 0 is 0. 1 times 5 is 5. Now, when I start in on the next number, my answers we're going to indent it in one line because that's where it's at. So 1 times 1 is 1. 1 times 0, 0. 1 times 5 is 5. And now we're just going to add. So this is going to be 1. 0 plus 1 is 1. This is going to be 5. And this is going to be 5. Now what I'm going to do is I am going to count how many places behind my decimal point. So I got 1, 2, 3. And then I'm going to start all the way to the far right, and I'm going to move my decimal place 3 times to the left. So my answer would be 5.511. That makes sense? All right, so the last one is going to be division, okay? And so when we divide, what we have to make sure, and we'll just use the same numbers again. So if I have 5.01 divided by 1.1, okay? So the first number, just like the top number when we're doing fractions, when we're dividing the fractions, the first number is always what's going to go inside the house, okay? So we have 5.01 divided by, so this line right here, y'all, means divided by. So we have 5.01 divided by 1.1. So we have 5.01 divided by that line, 1.1. So remember, when we do division, it has to be divided by a whole number. Okay, so we're going to make this outside number a whole number. And whatever we do to the outside, we have to do to the inside. So what's done outside must do inside. So I'm going to take this decimal point and move it one place to the right to make that an 11. Okay. Now, because I moved this decimal one place to the right on the outside, I got to move it one place to the right on the inside. And then I'm going to go ahead and bring this up because at this point, that decimal place will not change again. Okay. So, and then I always rewrite it because all these lines can get me confused. So I have 50.1 and my decimal point is going to be right here. Okay. So now how many times does 11 go into 50? We have 4 times. 4 times 11 is 44. And then when I subtract 44 from 50, I get 6. Now, can 11 go into 6? It can't, so I'm going to bring down my 1. So now, how many times does 11 go into 61? It's going to be 5 times. So 5 times 11 is 55. All right, and when we do our math, we're going to have 6. All right, so on the exam, it's going to tell you whether you have to round or if you have to carry. Okay, and on this one, I want you to carry your answer to the hundredths place. All right, so if we're carrying it to the hundredths place, can I stop right here?
No.
Okay, so what do I need to do?
Add another 0.
All right, so since that 11 can't go into that, whoops, that 60, gonna add another 0. And then how many times does 11 go into 60? It's gonna be out 5, which gives us 55 and gives us 5 left. Whoops. All right, so now since it says carry to the hundreds, can I stop right here?
Yes.
Yes, okay, because since it says carry, that means we're going to go to the hundreds place, which is right here, and we're just going to stop, okay? So I don't need to go one more because I'm not rounding, okay? So my answer would be 4.55. All right, any questions on decimals? So the decimals, y'all, are really the biggest ones that's got a lot of the rules to remember, okay? So add and subtraction, remember, they always have to line up, okay? Multiplication, you're going to multiply just like those decimals are not in there, and then you're going to count how many spaces after, and that's how many times we're going to move it to the left, okay? And then on that division, this outside number always has to be made. If it's not a whole number already, we have to make it into a whole number. Okay. All right, does everybody have the rules on this page written down? I know my handwriting's got messy on this little board thing, but. All right, so now. Forgetting. So don't forget that you will have a problem like this. Okay, so don't forget you'll need to know how to borrow with all those zeros, okay? All right, let's see.
You mean just like regular subtraction?
Yeah, just regular subtraction, but just with all those zeros and borrowing, okay? I think maybe the last thing is that the is over of equals percent 100.
Yes, please.
Okay, I think that's the last thing. So is over of times, no. Is over of equals percent 100. All right. So on this one, so remember when we have to borrow with these, the first one's going to be 10. All the rest of the zeros would be 9. And then whatever that last number is, it'll be one less. Okay. So you would have 8, 6, 8, and 8. Okay. You will have a question like that or a problem like that on the test. All right. All right. So let's do our word problems. Okay. You will have 3 word problems on the exam. It's going to be 60 questions total. Actually, I need to email Miss Bajeron. So it'll be worth 60 points instead of 50 points. There'll be 1 point apiece. And then 13, I believe 13 of them is the equivalence ones, like where, you know, sorry, 1 tablespoon equals 3 teaspoons, a teaspoon equals 5 meals, gram equals 1,000 milligrams, all of those.
Is that going to be in
okay?
like a word problem, or is that just?
No, it's going to be fill in the blank. So you're
Okay.
going to have to know it. Okay. So
Okay.
it's not going to be, you won't be able to pick it. Okay.
About how many of those did you say we're gonna
It's,
be?
I want to say it's like 13 to 15. It's between 13 and 15
Oh,
of those. And then the rest will be, word type problems. Oh, I know what else we didn't do. You're also going to have rounding. Okay. So let's say we have 1.25. Let's see, we have 0.1, 2, say we have 2, 3.347. All right, so on this first one, if we round it to the 10th place, what would our results be?
1.3.
Okay, so 1.3. Okay, so since this is my 10th place right here, okay, and since this is 5 or above, we're going to go up 1, so 1.3. Okay, so this one, let's round to the 10th again. What would we get?
0.1.
Okay, so this is my 10th place. Since this is below 5, it's going to stay the same. So it'll be 0.1. Now on this one, let's go to the 100th place. What would my answer be? So where is my 100th place? So I have my 10th place right here. And then my 100th place is going to be right next to it. So I need this number to see what I'm going to do with my 4. So it's above 5. So what are we going to do?
23.35.
23.35. Okay. So you will have several rounding questions on there too. Okay. Let's make sure. All right, so next, let's do our word problems. All right, So in order, now there's different ways to do the word problems, y'all. You don't, whoops, you don't have to use this little formula, but I found that using this formula, y'all, I could never do word problems before this formula. So, so is over of equals 100. All right, so if it says, what is 2% of 11? All right, so when we work this problem, what we're going to do is we're going to take our little formula right here. Is over of equals percent 100. So my question's asking me what is. So do I know is? Is it telling me what is, or do I need to find out what it is?
And out.
I need to find out. So it's going to be an X, okay? Now, remember this 100, it will never change, so we can go ahead and write our 100 in there. So it says, what is 2%? So do I know what my percent is? It's going to be 2 of 11. So do I know what my of is? It says of 11. Okay, so now, since this has an equal sign, how am I going to multiply?
Cross.
Diagonal, okay? So 11 times 2 is 22. And 100 times x is 100x. Now, remember earlier when we did ratio and proportions, how do I get that x by itself?
Multiply.
Not multiply, but remember we're going to divide each side by that 100. Okay, so now my 100s are going to cancel out. And then I'm going to divide 22 by 100, which is going to give me 0.22. Does that make sense?
Or the fraction, huh?
What's that?
Or we could turn that one into the lowest, the fraction, a fraction.
Actually, no, this one you'll have to divide it to be the number. Now, let me show y'all a little quick. Let me show y'all, and we're going to go back to this, but let me show y'all a quick thing to use where you don't have to really do the long division, okay? So let's say, all right, so let's say with, this is we're gonna do it two different ways, okay? So we have 1,000 times 0, 0, 2, 3, 100 times 2, 10, 1, 0, 1, 2, 1, 1. All right, so let's talk about how to do this easy in your head, okay, versus having to do the long division, okay? So when we say 1,000 times 10.3, excuse me, 23, you would have to multiply 1,000 times 10.23, okay? So this is going to take, it's going to be a lot of dividing and multiply. I mean, it's going to be a lot of multiplying than adding, okay? So a quick way that anytime you are multiplying anything times something such as 10, hundreds, thousands, 10,000s, what you're going to do is when we multiply, you're making a number bigger, okay? All right, so if you're making a number bigger, if you're multiplying something times, again, 10, hundred, thousands, what you're going to do is you're going to take this 10, I'm going to count how many zeros do I have, okay? I have 1 0, okay? And so since this is going to make this, since I'm multiplying times 10 and multiplication is going to make it bigger, I'm going to take my decimal and I'm going to move it one place to the right because I have 1 0. So my answer would be 1,101. Okay, so this one, I have 2 zeros. Okay, so I'm going to take this decimal point and I'm making it bigger, right? So I'm going to move it 2 places to the right. And I have 12. Because before I had partial of a number, right? I had 0.12. Well, now I have 12. So it's 12 bigger than this. It is. Okay. So this one, you have 1, 2, 3 zeros. So you will move that decimal place 3 places to the right. Okay. And since we have a third one that doesn't have a number in it, we're going to add the 0. So it's going to be 10,230. Okay. So especially when you're not being able to use the calculator, this to be able to multiply, especially when you're doing ratio and proportion, because with ratio and proportion, you're dividing everything by 100, right? Okay. So does this make sense? On a quick little tip. Okay. All right. So now when we're doing division, when we're dividing, we're making the number smaller. Okay. So we're making it smaller. So again, if we're multiplying times anything like 10, 100, 1,000, 10,000s, what I'm going to do is I'm going to take how many zeros I have, which is 1. And since I'm making the number, right over here. So this one we're going to move to the right. Okay. This one we're going to move to the left because we're making the number smaller. So if I have 1 0, I'm going to move it one place to the left. And then I have 1.023. And remember, we started with 10.23. So is 1.23, is it smaller than 10? Yes. Okay. So the next one, if I'm dividing by 100, I have 2 zeros. So I'm going to move 2 places to the left. And remember, anywhere that I do a little hump thing, I have to add a 0 if there's not a number there. So I'm going to have 0, 0, 1. Is that the correct way to write it?
No.
What do I need?
Decimal and 0.
My decimal and my 0. So it would be 0.001. Okay. Now, let's say I'm dividing the 23.24 divided by 1,000. How many zeros do I have? I have 1, 2, 3. So that decimal is going to move 3 places. 1, 2, 3 to the left. So I have 0.02324. Does that make sense? Does that help any?
Yes.
Yeah.
Okay. There is a section in the calculations book, okay? It's one of the first 4 chapters, I can't remember, but they go over this in there. And so they have some practice problems like at the end of that chapter on using, you know, the moving to the left and moving to the right with the tens, hundreds, thousands, 10,000s, like if you want to practice them. Also, you can also Google, there's a lot of free math worksheets online and they'll give you the answers. And you can go in specifically, because I've gone in and did these before for the students, where you can go in and specifically they'll give you a whole worksheet with these and you can work them and then they'll have the answers to them. But this just makes your life easier when you have to do stuff by hand, okay? All right, so let's do some more. Does anybody need to copy anything else off of here before I delete it? Okay. All right, so then let's do some more of the is over of percentage over 100, okay? So, all right.
What about the conversion word problems? You said we're gonna have 2 of those.
Yeah, so that's gonna be like these is-os. Actually, it's gonna be 3. So that's gonna be the is over of ones, okay? Okay, equals percent over 100. Okay, so it's gonna be like these. So it's gonna say, let's see. Let me think of how to word it. Which one we did just now? What is? Okay, so let's do 10% is 12 of what number? Okay. So, all right, so if we're using our formula, remember our hundred's always going to go right here. All right, so 10%. So this is giving us our what? Our percent. Okay. 10% is 12. So do we have our is? Yes, is 12. And then it's asking us of what? So do we know what our of is? We do not. So that's going to be our x. Okay. All right. So remember, since it's a ratio, because it's got that equal sign, we're going to cross multiply. Okay. So if we think about what we just talked about, if I'm multiplying, I can count these 2 zeros. Okay. 1, 2. And I'm just going to add them. I'm going to move 2 places to the right, which is going to give me 1200. All right, and then 10 times x is 10x. So now, to get x by itself, I'm going to divide by 10. And again, if we think about what we just learned, when we're dividing by 10, I have 1 0. So I'm going to go 1 place to the left. So my answer would be 120. Does that make sense? Okay. All right. So let's do another one. So we did one for is, we did one for of. Okay, so let's do one for, let's do this. Let's say the patient drank 8 ounces of his water. What percentage did he drink? All right, so let's think of our formula over here, okay? So remember that 100's always going to stay the same, okay? So we have, so it's asking us what percentage. So do we know our percentage?
No.
Okay. All right. You know what? Wait, I don't think I worded this one right. Hold on a second. No, hold on a second. I'm missing a number. Patient drank 8% of his water. Let's see.
Is 8 ounces the or no?
I think I'm missing a number. Hold on a second. I'm trying to see how I need to.
Like the size of the water bottle.
Yeah. Let's see. Patient drank 8 ounces of his, let's say 12-ounce water. Okay. So what percentage did he drink? Okay. So the of is what? 12. Okay. And then the only thing that's left is the is. So it's going to be our 8. Does that make sense? So our percentage, we know we don't have it because it says what is. It says of his 12-ounce. So that's going to be our of. And then the only thing else left is that 8-ounce. Okay. So 12 times x is 12x. 8 times 100 is what? 800. Y'all, I didn't give y'all any big numbers on the test, okay? And I made sure I reviewed it again this time and make sure that everything was small so y'all not dealing with big numbers on the test, okay? Let's see. Okay. So if we divide 800 by 12, it's going to give us 66.6% that he drank. All right, so remember the is over the of equals percent 100. That formula will not be on the test. So you'll have to memorize that, okay? And you'll know for the 3 word problem ones that you're going to use this to plug in your percent, your is, your of, etc. Okay? All right, and then one other thing that I forgot that's going to be on the test is those conversions. So let's do a couple of those, okay? All right, so remember, we did these, I think we did these the last day we did tutoring class. So let's say we had 10 teaspoons equals how many tablespoons? And actually, the small t, y'all, I'm sorry, I gotta get used to doing it the way y'all do it. Okay, so the small t is teaspoons, the big T is tablespoons. So in order to convert this, what is the first thing I need to know? What is my conversion factor?
How
How
many
many
teaspoons are in
teaspoons equals tablespoons?
how many teaspoons are in a tablespoon?
Uh-huh. So how many?
Oh, 3.
3. Okay. So 3 teaspoons equals 1 tablespoon. Okay. So remember when we talked about when we do these, we always are going to start with what we're trying to find or what we want to end up with. So that's tablespoons. Okay. And then you're going to draw your 2 lines in your X so we can just fill in the blanks. Okay. And remember, anything that we want to keep, like this tablespoon, anything that's got tablespoons in the problem is going to have to be on the same line so we don't cancel it. And anything that we want to get rid of is going to be opposite of each other, okay, or diagonal from each other. So let's, and then remember, anytime we have a conversion factor, remember, they're married and committed to each other for life, okay? And so we will never, ever separate them. They will stay together forever, okay? So wherever the 3T goes, the 1T must go, okay? And wherever the 1T goes, the 3T must go, okay? So we have our capital T, which is tablespoons, and our problem has 1 tablespoon. So because I do not want my tablespoons to cancel, my T is going to go at the top. And it's committed and married to the 3 teaspoons. Now, I'm going to draw this line here because once I use it in my problem, I'm not going to use it again. Okay, it's not available for use anymore. Now, I still got to get rid of this teaspoon because I want to end up with tablespoons only. So now I have 10 teaspoons in my problem. So it's going to go at the top because remember, I want these teaspoons to cancel out. Okay. And then I'm just going to do a placeholder. So now when I am multiplying fractions, remember I'm going straight across. And remember, we know it's a fraction that we're multiplying fractions because it's got an X in the middle. So 1 times 10 is 10. And 1 times 3 is 3. And then we're gonna, can we leave it like this? Is this really telling us anything? It's not. So we're gonna change this or divide this. So 3 goes into 10. So 3 times. Let's do it this way. 3 times 3 is 9. We have 1 left over. So we have 3 and 1/3. So 10 teaspoons equals 3 and 1/3 tablespoons.
Please do another one.
Yes. All right. Does anybody need to write this one, finish writing this one down before I erase it?
Okay, Miss Sanchez.
Uh-huh.
Okay, the teaspoons. I'm confused.
Okay.
Teaspoons and tablespoons. Okay,
Okay.
we get that from the equivalents, the units that you gave us on the paper.
Correct. Correct. You would have to,
Oh,
yeah. So this part right here, this is those ones I told y'all to memorize because you
right.
would need them to do problems.
Oh, okay.
So if you didn't memorize this yet, it takes you won't be able to work the problem because you don't know the conversion. And y'all, on the math, it's all fill in the blank. It's no multiple choice, okay? It's like, can you do this math? Because in real life, well, you're going to have multiple choice on math. You're not. It's going to be, you have this dosage and you have to give this much and you have to convert it from this to that in order to give it, okay? So it just takes practice, okay? Skills in math, y'all. If you don't continuously practice it, you won't be able to get it.
Okay.
All right, so let's clear this one off and let's do another, okay?
Question, do we have a conversion?
There's going to be 2 on this test. And
Okay.
then in pharmacology, y'all, there's almost everything's going to have conversions in it. Okay. All right, so let's do another one. Let's do 12 liters equals how many milliliters? Okay, so what's the first thing that we have to know? What's our equivalent or our conversion factor?
Do you know how many milliliters are in a liter?
Okay, and how many is that? 1 liter equals how many milliliters?
1,000 milliliters.
1,000 milliliters. Okay, and again, if you don't know this part right here, you're not going to be able to, well, there's a move to the left and right thing, which is going from smaller to larger and stuff, but that confuses me. So if you know that way, you can do that, but I don't know, I can't wrap my brain around that way. All right, so what am I wanting to find? I'm trying to find milliliters, right? So I'm going to start with milliliters, and then I'm going to put my lines out there, okay? So remember, since I want to keep milliliters, and I have 1,000 milliliters in my problem, I got to have that at the top, right? Because that way they will not cancel. And this 1,000 milliliter is married to this 1 liter, so they have to stay together on the same side, okay? So now I'm looking, and I still got to get rid of this liter. All right, so I have 12 liters in my problem. And since I need this liter to cancel out, they're going to be diagonal of each other. Okay, and then I'm just going to put a placeholder. So now I'm going to cancel these out. and I'm going to do my math. 1 times 1 is 1. And then 1,000 times 12. And remember just now we said when we multiply by 1,000, I'm just going to count those zeros. 1, 2, 3. And I'm going to add them to that 12. 1, 2, 3. So 12,000 divided by 1, it's going to give me 12,000 milliliters.
Ooh, child, do another one.
So if we
Alright.
just know that
There's so many
that's the problem.
steps to it, you know, it's like we're doing all kind of,
It's really
so
not
like it's
that many steps.
subtraction, it's
That's the same thing
decimals,
as the
it's all
King
in
Henry
one.
thing.
Wait, what's that?
That's the same thing as the King Henry drinking milk stuff.
Yes,
Yes.
this one
Okay.
is because it's got the 1,000 and stuff. So if you know that way, you can do it that way. But the thing with the Henry thing is, let's say you have something like this one, where I say you have a patient who weighs 222 pounds. Okay, and you have to change that to kilograms. Okay, so since, what's our conversion factor for this, y'all? How many pounds equals a kilogram?
2.2.
2.2. Okay, so since this does not have any zeros, it doesn't have your 10,000, 100,000 in it, you won't be able to do the King Larry thing. You're going to have to know how to do it this way. Okay. All right. So, whoops. Let me take this one off. All right. So if we're doing this one, what am I going to, when I'm setting up my problem, what am I trying to find? What's my end result? I want my end result to be in what?
Kilograms.
Kilograms. Okay. So, and then I'm going to draw my little lines, my X and my line. Okay. So now, what has kilograms in my problem? 1 kilogram. And I'm going to put that at the top, because remember, I don't want them to cancel out. And because it's married to the 2.2, they're going to be on the same side. They're going to stay together. Okay. And then I can draw a line through this. So now, since I need to get rid of my pounds, and I have 222 pounds right here, I want this one at the top because I want those pounds to be diagonal so they can cancel out. Okay. So 222 pounds. And then remember, my 1 is just a placeholder. So now you're going to cancel out these pounds. So 222 times 1 is 222. And 2.2 times 1 is 2.2. And y'all, I'm not going to give you big numbers like this on the test. It's just when I'm trying to pull numbers out my head, sometimes I end up with bigger numbers. So now what am I going to do? I'm going to divide that 222 by 2.2. And we're going to get 100.9. So our patient's weight in kilograms would be 100.9. Yeah, there's actually there's 3 whole chapters, y'all, with converting between units. Okay. So second, let me look at something real quick. So second. All right, so for the conversions on the test, okay, there's going to be 1, 2, 3, 4, 5, 6. So there's going to be 13 of the ones where you just have to give them conversions, like milligrams, grams to milligrams, grains and milligrams, all of those things, okay? You're going to have 2 problems like what we just did. One of them is going to be kilograms and pounds, and one of them is going to be milliliters and liters. Okay, you're only going to have 2 of them on there. Okay, but you still have to know all those other conversion factors, right? Because you're going to have 13 on those that you're going to have to write what they are. Okay. Oh, I know what else we didn't do. All right, don't forget we're going to have military time. Okay, what time? Put this in the chat. What time is this in regular time? I forget what they call it. What time is this in regular time? Okay. What time is, all right, so remember with military time, there's no colon, there's no AM, no PM, okay? With our regular time, you have to have the colon and then you have to have the AM or PM, okay? All right, then don't forget you will have Roman numerals, okay? What is that one? Let's see, what is this one? Okay, how do you write this one and this one? Okay, let's see, let me do another one on here. Let's do 1:02 a.m. All right, let's see what else is on there. Okay, we did that. We did those. We did that. Let's see. We did those. So we did those. Okay. All right, I think we've gone over everything else. Let me just make sure we did ratio and proportion. We did converting. We did word problems. All right, let's see. Okay. All right, so don't forget with your regular time, if it doesn't have the AM or the PM, it would be incorrect, okay? All right, and let's see. All right. All right, we did those. All right, so let's take a look at them. All right, so this first one is going to be 12 a.m. Okay, and then our second one is going to be 1:52 p.m. All right, and then our 11:59 p.m. is going to be 23:59. And then our 1:02 a.m. is going to be 01:02. Okay, so with our Roman numerals, we're going to have, so
You
this
said
one,
no colons, huh, Miss Sanchez?
correct. So no colons with your military, but for your regular time, it will have the colons and it will have AM and PM. But military time, y'all, is straight numbers only, okay? No colons, no AMs, no PMs, nothing like that. Okay, so now let's look at this Roman numeral. What's the V? So the V is going to be 5, okay? And this is a 1, so it's 5. If the 1 is before it, means you subtract. So 5 minus 1 is 4. Okay? Now, on this one, what's our X? Our X is 10. And if the lines are after it, means you add them. So 10 plus 3 is 13. Okay, so this one is, well, this number is 9. So we're going to have our x, and then we're going to have our 1. So x is 10. We subtract the 1, which gives us our 9. And then on our 3, so it's going to be our 3 ones.
Now, Miss Sanchez, how you do like
I'm sorry,
one
what's
of
that?
them? How you do like for the Roman numerals? Like if it was like, let's say 17, would it be
So,
go ahead.
so 17, it would be, we have 7, right, it'd be, I believe it would be this, but let me look it up.
That's right.
Is that right? Okay. So we have our 10, and then we have 5 plus 2, which equals our 7. And then when we add them up, it equals 17. So in your calculations book, y'all, there's a little, the page of information that talks about the Roman numerals. It tells you there's, number one, there's a way to memorize, like there's a little saying to memorize what each of the alphabets mean, you know, the X, the V, the M, the C. But the other thing in there, it tells you the rules, like how do you know to put, you know, the line before? How do you know to put the lines after? How do you know what order to put them in? So there's rules in there that tells you those things that's going to help you figure out what the number is or how I need to write the number. And I really only make y'all, I don't give y'all any higher numbers than 20. I try to use kind of those numbers that y'all gonna see.
Bless you.
Yeah, I don't, we're trying to make y'all do, I mean, I remember them trying to, like, we had to give, like, write out 1,300. And I'm like, I'm never going to use this in real life. So I really try to give y'all, the things that, you're going to use and it's going to be useful versus making you try to memorize a bunch of stuff that's not useful to your practice.
Thank you. I had a question about
Question, Doctor. Oh, go ahead.
Okay, go ahead.
so how is 0012 12 a.m.?
So once we hit midnight, okay, so or 12 a.m. Okay, so 12 a.m. is 0, 0, 0, 0. Okay, that's 12 a.m. Okay, so this is going to be 12 after midnight. So it'll be 12, 12 a.m. Does that make sense?
Yes.
Okay.
Thank you.
All right. I had another question.
Yes. So for 9, the numeral, if I were to write V and the 4 ones after, that's still correct, correct?
No, that's incorrect because the Romans were superstitious and they believed that you could never have more than 3 things in a row. So if you put 4, that's superstitious, they would never have it. So they'll never have more than 3 of those alphabets in a row. Okay, so if you write the B 1, 2, 3, 4, that's incorrect. Okay.
Okay.
And that's where those rules come in. Like when you look in that chapter that's got the Roman numerals, that's where kind of those rules and stuff will come in, like what you can do and not do. But with Roman numerals, you're never going to have 4 of the same alphabet in a row because they were superstitious about that.
Okay, I have a question. We have it's a time test, so we have 60 minutes to do the test, or
So actually with math, we usually give y'all two it's usually 2 minutes per problem, but you'll get an hour and a half because like some of them was just rounding. It's not going to take you 2 minutes to do it. So it kind of gives and take for those areas. Like, the 4 problems or whatever with rounding is going to take you a couple seconds. The one to go from percentage to decimal or decimal to percentage, that's just a couple seconds. You're just moving that decimal. So it's going to be a 90-minute test with the 60 questions.
Okay, thank you.
But like when you get to form, it's usually 2 minutes per question. Because it's, you'll have to figure, read the question, pull out the information, and then work the problem.
So is form like D over H times Q equals X? Is that what we'll be using that equation?
Yes, for the most part. Okay, there will be some things that we won't be able to use that for, but in pharmacology, that's the majority of almost everything will be that that formula, but you may have to do conversions like between milligrams and grams and things before you can plug it into that formula.
Gotcha. Okay, thanks.
Okay, any other questions? All right, well, I will upload this, so if you need to go through it again or anybody else that wasn't able to make it, so as soon as it uploads and I can download it to my computer, and then I'll upload it to YouTube, and then I'll post in the, I'll post in the announcements that it's in there.
Ms. Sanchez,
Uh-huh.
can you help me tomorrow? I have not been able to access none of my assignments lately. That's why I haven't been able to get to do them because my browser is not
So what time do you get to campus on Monday? What time do you get there tomorrow?
I could get there as early as you want me to.
Okay, so I have a meet with Miss Jackson at 3. Hopefully I'll be done like 4:30, 5 o'clock. So I guess if you want to get there about 5 and
Okay.
just come upstairs and just tell them you need to see me and they'll get me.
Yes, ma'am. Thank you.
Okay. All right, any other questions or anything before we go?
Do we have tutoring tomorrow too or no?
Did I originally, I don't know, did I originally say, or did we just change it to today?
I think we changed it to today.
I think we changed it to today. So, yeah, so I would just rewatch this if you're still having issues, and then definitely go into your calculations book, within your vital source, your ebook, and do those practice questions. And they do have answers, we'll have the answers at the end of the chapter for the questions. All righty, well, if that's it, I will see y'all tomorrow at wait, no. Yeah, I do have, yeah, sorry, I do have y'all tomorrow. So what we have 108 fundamentals tomorrow, right?
Yeah.
All right, well, I will see y'all tomorrow afternoon. If y'all have any other questions or need anything, just shoot me a message.
Okay, thank you. Bye.
All right, y'all have a good rest
Good
of the
night.
day. Bye-bye.